Hey everyone, my name is Emma and we're going to talk about the most amazing element, oxygen, and how important it is to our amazing thing we call life. I would start with a fun little quote. We all have to do a presentation and we're all able to do it if we're able to say these crazy chemical compounds. So with that being said, let's talk about oxygen. So today we're going to start with some common knowledge and some really cool facts. Then we're going to talk about what makes oxygen oxygen and how that then plays a role in its chemical reactivity. And then we're just going to do a quick wrap up. Okay, so let's get started with some common knowledge. So something I already knew going into this is oxygen makes up about 2/3 of the human body and about 50% of the Earth's crust. But two new facts is while I did understand that oxygen does not make up a majority of our atmosphere, I did not realize how much of a difference between nitrogen that it had. It only makes up 21%, while nitrogen makes up around 40 to 50% of our atmosphere. But the one that really blew me away is oxygen is actually the third most abundant element in the entire universe, followed behind hydrogen and helium. And I think that's so interesting that even outside of our tiny blue rock floating through space, that oxygen is still prevalent throughout the entirety of the universe. And basically, long story short, oxygen is extremely important. Let's talk about its elemental properties. So oxygen is found on 8 in the periodic table. It has a molecular weight of 16 and an atomic number of 8. Its ground state configuration is 1s2, 2s2, 2p4, and it actually has slightly low melting points and boiling points, and that is because at room temperature, oxygen is found in a gas form. And with that in mind, its first ionization energy is 1314 kilojoules per mole. And then over here, we actually have two of the most common allotropes of oxygen. Oxygen is actually not usually found by itself. It is found in a diatomic molecule, O2, and that is what we know as oxygen gas. It also is formed, its second most common allotrope is ozone, or O3, which is 3 oxygen structure right here with a double bond that is delocalized between the 3 oxygens. And then there are also O4 and O8, which are not pretty common allotropes. They are actually only formed in extremely high pressure and temperature. They are actually metallic oxygens. They are red. I thought they were blue. No, oxygen is red when it is a metal. It blew my mind. And with that being said, let's talk about chemical reactivity. So when it comes to bonding, oxygen actually forms strong bonds with pretty much only hydrogen and carbon, but it actually forms weak sigma bonds with electronegative elements such as fluorine and chlorine, also including itself. And because of that weak bonding with itself, gives rise to ozone production. In fact, production of ozone has a delta H formation 143. Because of that weak OO bond, it's a strong oxidant, especially if you're comparing the oxidation of oxygen to ozone. Ozone produces around positive 2 volts, while oxygen produces around positive 1 volt. So it's actually a stronger oxidant. And so if we're talking about its reactivity with H, it actually, when talking about group 16 hydrides, we see hydrogen sulfide and hydrogen selenide. For oxygen, its hydride is water, and that actually has an extremely high intermolecular force compared to other group 16 hydrides due to the hydrogen bonding between the O's and H's within water. And because that also allows for those weak bonds between those O's and H's to give it this uniquely acidic property. And in terms of acidity, that also plays a role of how sulfur reacts with oxygen, producing SO3 sulfates. And sulfur is able to have an expanded octet, which means when it bonds with oxygen in either SO2 or SO3 forms, it's actually able to have multiple double bonded resonance expanded octets within it. So that allows for an extremely high oxidation state within SO3, which allows it to actually act as a Lewis acid. But however, when it reacts with water, it's able to produce sulfuric acid, or H2SO4, which is an extremely acidic and reactive compound. So with that being said, sulfuric acid, SO3, water are all extremely important in life and what comes with life in organic, inorganic biochem and biology, oxygen plays such a big role outside of aerobic respiration, but in the daily reactions that go on all around us. And oxygen is just so more complicated than one could ever thought. It was absolutely amazing to learn about it, and I hope that you enjoyed. Thank you.